Accounting for the links is the subtext for Project 7. And the aim really was for the application of a particular approach called collaborative conceptual modelling to identify cross-sector links in the urban complex and to understand the dynamics of the urban climate health system. Collaborative conceptual modelling, or CCM as we like to call it, has been developed by Barry Newell and myself here at the ANU as an approach for dealing with complexity in human environment systems. It's got a strong base in dynamics and cognitive science. So Project 7 actually had two parts, was played out in two parts in Australia, in Sydney or Western Sydney, and that was my domain, and in Perth, where Helen Brown did her studies, and she will talk about that after me. So we looked at the urban climate health system, and we looked at the projects 4, 5 and 6 that you've heard about, and we came to the conclusion for the Sydney part of it that we're going to focus on technology as a seriously important activity in urban systems. And we've come up with these two hypotheses that technology choice has major implications for health and climate adaptation, and there is a maladaptive dependence on technology has serious long-term implications for both environmental and human health, especially under climate change. So we looked more closely at the Western Sydney situation, and as an example of a technology we wanted to investigate, we selected refrigerated air conditioning, or RAC. It's a very important part of life in the developed world, but it is a double-edged sword. There are clearly positive health impacts for reducing the risk of heat stress, reducing insect-borne disease, generally increasing physical and intellectual activity when you're in a comfortable, cooled, pleasant environment. But there are also negative impacts, and especially because the cool, nice environment is indoors, people are not getting out and about. These people have higher food consumption and slower metabolisms. There's a potential to lose the ability to adapt to temperature extremes. There's generally low level of physical activity, and especially in children, there's recognition of this emerging disorder called nature deficit disorder. Children who remain indoors, and if it's hot, they'd rather be indoors, and also social isolation and mental health issues are being recognised as negative health impact with pleasant, cool, indoor climates. But the story is much more complex. I should just go back there. But the story is much more complex than just health. And when we need to look at the environmental system, and it gets a little more complex. We have here a diagram of feedback effects, which are still only part of a small part of the system. And it looks very complicated, but I'll try and unravel it a little bit. Let's start in the centre with there's a B, that's a balancing feedback loop, where the use of RAC is connected with the risk of thermal stress. So as the use increases, the risk of thermal stress decreases. But as the risk of thermal stress increases, so the use of RAC increases. So that's a balancing feedback loop. There are many reinforcing loops there as well, and these are very common in human systems, in urban systems. The use of RAC has an impact on our ability to acclimatise to local weather conditions, and this increases vulnerability to extreme weather. RAC puts a large load on the power generating system with consequent risk of power failure during heat waves, which then increases vulnerability. In the climate sector, it has unfortunate connections with the use of chlorinated refrigerants, many of which have been banned in the developed world, but have not been so banned in the developing world. And this is quite a worry in countries with large populations like China and India. The use of those refrigerants, of course, affects GHG emissions, climate change, frequency of heat wave conditions, and then back around to vulnerability and to the risk of thermal stress. That's one set of related reinforcing behaviours in the urban system. On the other side, we can focus on the supply industry of the technology. Two reinforcing loops, which are a system archetype of success to the successful, where you have where the dominant form of technology is RAC design and development. Then you have an industry that is geared to produce for houses that require RAC. The opposing or the complementary technology would be passive climate control, and that is the design of houses that are passively climate controlled, and the technology is developed for that. But the industry won't be geared to that when they're competing so hard with the RAC side of the technology. So there's a real success to the successful there, and at the moment RAC is winning hands down. So we face a complexity dilemma, and we need to study the interplay between all these sections of the system. But the system is highly complex. So the question really is, how can we make progress in this complex situation? In our work in Project 7, we have attempted to address this, and we have produced a set of conceptual models using system dynamics thinking and cognitive science. So our approach has involved 3 steps to produce these conceptual models. This is the first one, and it's a co-effects template. It has 3 sections: the population health, state of the urban complex, and the state of the environment. Very high-level variables that aggregate many dozens, hundreds of variables. And they each connect to produce 3 loops: the health effects loop, the environmental effects loop, and a co-effects, where if you do the right thing for human health and for environmental health, then the state of the environment will then look well on population health, producing that link 5. There's also the climate effects that are occurring much more slowly as a result of behaviour in the urban complex, but need to be looked at nonetheless. So this diagram essentially embodies work that was done by cluster project team members in the early part of the life of the cluster. And note that links 1 and 2 are essentially perception and policy making links, and links 2 and 4 are the activities that arise in the urban complex, and those activities have an effect on health and on the state of the environment. The next step is step 2. We produce a problem space, and we project that down into a particular problem area, which we've selected as technology choice. You can see the same pattern there as in the previous diagram, and the thing that has changed particularly is that the extent to which community depends on adaptive rather than maladaptive technologies is the particular area that we've looked at for the urban context. What is important there is urban decision makers' level of concern for future health and for future environmental outcomes. So the question is, what drives that level of concern? To answer that question, we looked to some experts in Western Sydney. We held some scenario workshops with urban planners and health professionals who are interested in the problems of Western Sydney. And this diagram was developed with them through 2 workshops. And they came up with 2 key variables that drive this level of concern. And one is the extent to which the health sector is proactive, and the extent to which urban policy and planning is integrative. So we have these 4 scenarios that describe conditions that will evolve by 2050. Scenario 1 is the business as usual kind of thing, where the health sector is not very proactive or not at all proactive, and urban policy and planning is fragmented. It moves to scenario B, where it's proactive but fragmented, and patchwork is integrative but reactive, and the best of all possible worlds we look for is in scenario D, where health sector will be proactive and the urban policy and planning will be integrative. So that was very interesting and useful interaction we had with experts in Western Sydney, and we took those ideas and brought them back to our problem space. So we added those 2 variables to the drivers of the decision makers' concern for future health and environmental outcomes. Okay. Then the 3rd step in this development of the conceptual models was drilling down a bit further to a system of interest, and this was the tension between refrigerated air conditioning and passive climate control. And here, the same basic pattern or template, we've now got dependence on passive indoor climate control rather than RAC as the main variable for the urban complex. A risk of thermal stress is the health issue. Average heat index is the environmental issue. And in between there, we have to have peak load on electricity supply and ability to acclimatise to local temperature regimes operating in loop links 2. And we are using these models, these systems of interest, we're using these as starting points for detailed dynamical studies. We've also developed one very simply after looking at private motor vehicles and imported food to reflect some of the interests of project 4 and 5 and 6. So these lead to dynamical studies, and we produce simple, low-order dynamical models with few variables. We're very much against large, complicated models, and we realise that you have to have something like this as a starting point to be able to really investigate specific issues in the urban complex. The last one, this is a graph, comes from research in the Netherlands, and these people have modelled RAC energy use using population, climate change and RAC penetration forecasts, and they make the interesting prediction that RAC demand for energy will overtake that of heating by about 2070, and this is something I think we should really be starting to get quite worried about. The causal loop on the side there is showing that climate conditions now are influencing the use of RAC, but after about 2050, RAC use will be influencing climate conditions, and we really need to think about that if we're also, and one of those things is to be thinking about the carbon intensity of power generation. And that's the last sidebar, this one. They can have the last one. Thank you.